So a lot of kids got stuck on this problem on Sapling. So just because there's something different, and we're going to have to use trig to get out of this. So before I get into this one specific problem, here I have a bunch of quarters, and if I stack them up really well, I can get like a right cylinder. My surface, my base is a circle, and then if I turn it around, you can see it's a cylinder. Now, what if I have the same group of quarters, and if I tilt it, if I tilt it, and if I were to find the volume of this bunch of quarters, you know, it doesn't matter if it's slanted or if it's perfectly making a right angle with the bottom, it's still the same volume. So, based on that, we're going to be able to find the volume of this oblique prism, but we don't have the height here. But we do have the angle that the prism makes with the bottom, which is 60 degrees. Now, we really need the height to find the volume, but we only have the lateral edge, which is right here. Since the height makes a 90 degree with the bottom, if you look at this as if this was a triangle, and this, I know it's 60, we can just use sine of 60 to find the height. So I know sine of 60 is the opposite side over the hypotenuse. So opposite of 60 is the height. Hypotenuse right here is given 12.7. Right there. Right there. So on your pretty little graphing calculator, make sure you have right there in degrees. So sine of 60, you're cross multiplying right there. So times 12.7. We can just go ahead and round it to 11. So the height here is 11 centimeters. Now, it doesn't get any easier than that because everybody knows the formula to find the volume of the prism. And you know that the capital B is the area of the base. For you to find the area of a rectangular base, you know you multiply the base, the length times the width, and then h is the height that you just found, 11. So this is to find the area of the base, and then you multiply by the height of that prism. So you plug that in the pretty calculator, and you get the volume of this prism. So 165 centimeters cubic centimeters right there. Pretty. Now, one more also from Sapling. We have this pretty company trying to build a cylindrical above ground pool. So I'm going to draw my pool, cylindrical, right there. Make sure it's not too deep, that way you don't drown. The inside diameter is 15 feet. And the inside depth right there is 5 feet and 6 inches. So 5 feet, 6 inches. Everybody knows 1 foot is 12 inches. 6 inches, half foot. So 5.5 feet. Now we have two questions to answer. One, how much is required to build the inside walls? So we're not talking about the bottom, we're not talking about the cover, we're only talking about the walls. So we're looking for the lateral area. So we have the pretty formula right there, so 2 pi r times the height. We're using 3.14 for pi. The radius right here, be careful, because the 15 feet is the diameter, and everybody knows the diameter is twice the radius, so we have to cut this in half. So 7.5 times the height of the pool, or the depth of the pool. Plug it in. the lateral area. That's how much wall you're gonna need. So 259.05 square feet. That's question 1. Now the other question is, what is the total amount of vinyl, including floor, including the walls, and the cover? This one is easy. This one we've done before. So we need to do the total surface area. And your formula is this pretty thing. So pi is 314. Radius, don't forget that it's half of the diameter right there. 7.5. So the depth of the swimming pool, 5.5. And the radius again. Voila! 612.3. That is including the wall and the cover. Cool beans.